Hey kiddos, so I want to show you how to do a T-chart because there might be graphs that we have to do for half-life, but we may also have to create a chart, it's called a T-chart, in order to set up a problem, okay? So in this problem, we're going to need to set up a T-chart, so I'm going to go ahead, I'm going to move over here, and I'm going to draw that T-chart over here. Now, guess why it's called a T-chart? Because it looks like a T, okay? I like to do mine like a little T because I like to separate where my headings are, but we just make a heading on the left side, and that heading is time. On the right side, the heading is amount, okay? And yes, I can see it's crooked, but we're going to be all right. I'm not worried about all that. In the problem, we can read and find out what our starting amount is and what the amount of time is for a half-life. So if we look at number 12, it says if you have 100 grams of a radioactive isotope, this is our starting amount, and it has a half-life of this much time, then we use that to set up our table. So remember at the very beginning, this is the only mistake that people commonly make, and it throws them off on their chart, is the time has to start out at 0, because at the very beginning, we haven't had any time pass, and we have our starting amount. So starting amount is 100 grams, started out with 0 time. Then the first entry for the time after that is 1 half-life. It tells us that is 10 years. And then we're just going to do something to get the rest of our answers. So how do we get these other answers? We have to remember our definition of half-life is the time it takes for our sample to decrease by half. So what we're going to do on this table is every time we go to the next amount of time, we're just going to add 10 for the half-life, because this half-life is 10. So we're going to add 10 years each time. Well, that's easy. We can do that without a calculator. Sometimes you will need a calculator, though. The amount, sometimes we need a calculator for it, too. We just cut it in half every time. So for this, we just divide by 2. And then for the next one, we're going to divide by 2 again. And we just keep going. So you have to be neat with your table, or else things aren't going to line up and you're going to get all confused. So if you have to do this on something with lines, then do that. So we're going to start out at our first half-life of 10 years. What does this amount become? It cuts in half, so half of 100 is 50. And then in these questions, if you kind of look ahead, you're going to notice we're going to need to go all the way to 40. So let's go ahead and do that. Okay, we add 10 more to 10, that makes it 20, plus 10 again is going to be 30, plus 10 again is going to be 40. So this is where we're going to stop. All right, so we did 2 of these. So at 20 years, we have to cut 50 in half. So what are we going to have? 25. And then over here, what's half of 25? It's going to be 12.5. Remember, you can use a calculator. Then at this one, after we've gone through another half-life, that's going to be half of 12.5, which is 6.25. All right? So now we can answer our questions now that we've completed this chart. That's really all there is to T-charts. So let's answer these questions. If you have 100 grams of a radioactive isotope, blah, 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 how much do you have left after 10 years? It's on the chart. 50 grams. How much will you have left after 20 years? That's going to be 25 grams. And then this doesn't ask what's the total amount of time, or what's the total amount that you have left. This is asking how many half-lives. So how many half-lives did we have to go through? Remember, don't count the very first one, because that's not a half-life yet. So we have 1, 2, 3, 4 half-lives. Okay, so there might be maybe one question on your test where we actually have to figure out how much remains or what was the original amount. So I'm going to show you how to do that next. Let me get it set up. All right, so this one is going to be a little tricky because you're going to have to really think about the amount that was given and or give the information that's given and have to figure out how to solve for this. Okay? As we're looking at this, I want you to notice that it tells us the half-life of this sample is 14.3 days. We're given a T-chart, okay, because I'm not going to be able to draw this and it look really neat. But it tells us if there's 0.125 grams left after a certain amount of time, what is the amount of the original sample? And I feel like this is not recording.